Okay, hi guys. So here is cycle K phase 4. So the derivative of the reciprocal function. So the reciprocal function is 1 over x, and we would just convert it like this, and then we would go negative 1 x to the negative 2. So negative x to the negative 2. That'd be the derivative. But the antiderivative, here we use the power rule for derivatives, which you're used to doing. But then maybe you say to yourself, oh, I could use the power rule for antiderivatives, which I did up here. So I converted to ax to the n coefficient divided by the new exponent. So negative 1 plus 1 is 0. Guys, you can't do it. You'd be dividing by 0. So then, you have to ask yourself, well, what if you took the derivative and got 1 over x, then what was the original? If you took the derivative and got 1 over x, then what was the original? And the answer is natural log. Okay, it's natural log of x, but I'll tell you why in a minute. But for the antiderivatives, you have to put absolute values around the input. All right, so I should just tell you why. All right. So basically, guys, is this it? Okay. So basically, this is the natural log of x. And then when you take its derivative, you end up with 1 over x. But actually, guys, the domain here, we don't really talk about it, but the domain here is restricted because so the 1 over x, if you just thought of the reciprocal function 1 over x, its graph is this. All right, that's its graph. But this, if we're talking about the derivative of this function in this context, if we're thinking of 1 over x as the derivative of natural log, then, guys, you can't have this negative part. So really, when we're talking about 1 over x as the derivative of natural log, it's just sort of implied that we're only looking at the positive part of the 1 over x graph. Because this original function, if we don't even have a domain over here, then we can't have a derivative over there. So there's that. So that's why if we're going backwards, okay, so if we're going backwards and we're starting with this function, then when we do its antiderivative, which ends up being natural log of x, we have to restrict the domain because over here, and if this doesn't make sense to you, please don't even worry about it. But I'm just trying to explain why we have to have the absolute values. If we're going backwards, this domain is like all of these values. So if we want to say that the antiderivative is natural log of x plus c, that's not good enough because in this context of going backwards, x could take on any of these values. So just saying natural log of x is not good enough because in this context, x could be negative. And you can't plug a negative into a natural log. That's why we need, if you're going backwards, that's why we need the absolute values. To take the derivative of this, you don't need the absolute values. It's just like implied that you can't plug negatives in here. But going backwards, we do need them. Okay, sorry if that confused you. Don't even worry about it, guys. You just have to know you just have to know this, that the antiderivative of 1 over x is that with the absolute values. Okay, so here's some examples. Let's do 2 of them. So number 1, pull out any constants if you can, guys. So I'm going to pull out a 1/4. All right, and then you can bring down the 1/4. what's the antiderivative of 1 over x? It's natural log of the absolute value of x plus c. Okay. Can you pull out any constants? Yes, I could pull that 2 out. I bring the 2 down. What's the antiderivative of 1 over x? It's natural log absolute value of x plus c. Okay, now moving on. Here is a formula to know. So here's a formula to know. I call it the f prime over f formula. So if you're taking the antiderivative of some input and the numerator is the derivative of the denominator, then its antiderivative is given by this formula. Natural log absolute value of f plus c. All right, so here we have numerator equals the derivative of denominator. So if you're taking the integral or the antiderivative of something like that, then, all right, and this is actually very closely related to this formula because let me ask you this, what's the derivative of x? What's the derivative of x? 1. So here we do have a situation where the numerator is the derivative of the denominator. All right, so the proof of this formula actually does, it comes kind of from that. Okay, so now, the next set of exercises is trying to get you to identify when you can use this. Okay, so here. For each integral, or antiderivative, determine if it can be found using the f prime over f formula, and if so, use the formula to evaluate the integral. If the integral cannot be evaluated using that formula, then just skip it. Don't even worry about it. All right, so, so we'll just do number 1. All right, so we're trying to see if this is of the form f prime over f. So, let me think how we should do it. Okay, I'll be like, let f equal the denominator, always the denominator. Then f prime, or the derivative of 7 is just 0. The derivative of e to the 5x, we actually need, this situation. So that'd be 5e to the 5x. So guys, do we have f prime over f? F prime over f. F prime f. Yeah, we have it. Okay, so I'll be like, so maybe I'll just go like this. Then, I'm just trying to think of how I could write this nicely for you. 5e to the 5x. Dx is equal to this, okay? And now we use the formula, and then this is equal to the natural log of the absolute value of f plus c. Okay, I am just using this formula. So once I've identified that I have this, I could use this formula. But then what is f? F is the denominator. 7 plus e to the 5x plus c. Guys, if you could jump immediately from recognizing, aha, I have the form, you don't have to show these 2 steps in between. Okay, I'm just showing you where, the logic I'm trying to. All right, now number 2. So we got to see if we can even use f prime over f here. Yeah, I think we can actually. So I'll do more than... I want to find one where it doesn't work. All right, so let me do, I'm kind of giving away that some of these work. All right, let me do number 2 and then I'll do another one. All right, just so we can get the hang of it. All right, so I'm going to let f equal the denominator. and then I find f prime. And then I ask, is this f prime over f? This is f prime. If this is f, is that f prime? If the bottom is f, is the top f prime? Yes. Okay. So we do have it. So yeah. Shoot. Okay, so we've got 3x squared over x to the third plus 5. And then, so this is equal to f prime over f, which its antiderivative is this. And then f is x to the third plus 5 plus c. All right, that's number 2. Now, let's look at number 5. Number 5. So you let f be the denominator. So f equals 18x to the 5th minus 2. So then f prime is equal to 18 times 5, I don't even know. 90? I think it's 90. Yeah. So f prime is 90f to the 4th. So this needs to be so bottom, top. There's the bottom. The top is not it. Okay, so not at all. So number 5, can't do. Can't use. Okay, guys. So, yeah, just here's a bunch of practice. And I have the work attached.